evening, everyone. And first of all, thank you everyone for registering to today's speaker series. So let me use this opportunity to thank Suman Debnath, for taking his valuable time to honoring our stage. And before starting the session, I also love to give a quick intro about DCKAP, the organization behind the speaker series. So DCKAP is a digital commerce agency and helping businesses and brands abroad to create e-commerce storefronts. So that said, during these challenging times and being in lockdown, and I believe it is very much important for every one of us to hone our skills, to learn new things, to facilitate learning for our employees as well as for the general community. So DCCAP started hosting the speaker series, a virtual event that happens every Friday. And through speaker series, we bring in distinguished thought leaders, technology masters, and change makers around the globe to address on varied topics and which matters the community most. And I would probably say it's been 3 months, every Friday, we have the thought leaders from the different industry to address our community. So, having said that, I'm glad and proud to welcome Suman Debnath, a principal developer advocate at Amazon Web Services. So, he's a passionate about big data, machine learning, and deep learning. And prior to joining AWS, he have worked at various organizations like IBM Software Lab, EMC, NetApp, and Toshiba, where he worked with system and performance engineering teams and focusing on storage protocols. And Suman is also pursuing his MTech in artificial intelligence from IIT Jodhpur. And I would say Suman has a vast experience of working on storage performance measurement, and he has authored more than 50 white papers on performance benchmarking and monitoring for Hitachi and IBM. And no, he has honored multiple stages, and recently the PyCon, the massive event for Python community, he honored the stage. And very recent, I would say, he honored the stage of Analytics Media magazine on deep learning, and where he hosted a workshop for the viewers. So that happened yesterday. I believe his calendar is very full for hosting events, so he's spreading his knowledge. So that which is completely amazing. And Suman, you inspire us, and we love to learn from you. And today he is about to enlighten us on intriguing topics. So that is deep learning on Amazon Web Services. I hope you guys will have a great session today. And if you have any questions, feel free to raise your questions in the Q&A section that you can see at the bottom of your Zoom panel. And over to you, Suman.
Sure. Thank you so much, Rija. And let me first share my screen. All right. Thank you so much, everyone, for joining in, and thanks, Rija, for overwhelming, welcome note. Honestly, I'm not that busy. It's just I pretend to be busy, and yeah, it's great, to talk to people and the community. I was just going over the attendees, and I know a lot of people in this list. I'm so glad that I got this opportunity to interact with everyone. And what we are going to do today is we are going to look into deep learning at a very high level. We'll try to get inside a few of the things in deep learning that we have, and how you can, what are the tool sets and what are the services that you can use, on deep learning on AWS. Okay, we will discuss a few things on those lines. Having said that, due to the time and the structure of this talk, we may not be able to cover everything, but feel free to post your questions in the chat. I will try to cover that during the session, or maybe towards the end, or after the session, over various social media platform. Okay, so but the idea is to interact and know you better, so that we can help each other going forward. Okay, so having that, with that said, Let's get started with our the topic for the today. It's deep learning. So if you look around, AI or machine learning in general is kind of a very hot topic all around the globe, right? And we are kind of a user of AI directly or indirectly. No matter we are a software engineer or an electrical engineer, or we are not at all into the tech space, right? Whoever we are trying to we are using AI or machine learning, right? So think about Zomato or Ola cabs or anything like Netflix we watch every day. So everything is driven by some kind of machine learning in today's world. So it's always good to learn AI if we are new to technology, or we are studying that, or we want to leverage something in the tech space going forward. So this is the best time to learn. And honestly, I'm also not from this field. I've spent almost a decade into storage engineering and protocol development and performance engineering, but I felt that this is the right time to look forward to the next wave of technology. So now when we talk about machine learning or AI, you can think of it as broad, biggest umbrella that we have, which covers, or rather, you can think of it as a space where, if you think of an idea which can mimic your human brain or which can take decisions of its own, then we can prototype that as an artificial intelligence application, right? Example would be an automotive car that we have, like Tesla, that we all know, and then robotic room cleaners, right? Nowadays, I can clean my room, which is located in a remote place, sitting in Bangalore, right? So these are the applications or the end product, what comes under AI. But how we can achieve that? To do that, we need to we need to use some statistical tool or machine learning algorithm and learn from the pattern, right? So this is where machine learning comes in. So to achieve what AI thinks that can be achievable, is delivered by machine learning algorithms, or the models that we develop, right? Because at the end of the day, it is just like you are trying to build a model which can predict, right? And how you what is that model? It's not a software code, or just a program that we write in in normal computer science classical problem. It is, you need to train a model based on some data. So it tries to learn the pattern from the data that you give. Okay, and how it learns, there are some standard algorithms, or there are different statistical techniques available which can help us with doing that. And then we have deep learning, which is a specialized area within machine learning. It's again a subset of machine learning, where it caters various complex problems, like let's say speech recognition, or image classification, or you can think about language translation and all of that. So if you have Alexa at home, or if you have any device like that, those all are been driven by deep learning, right? So it solves a lot of complex problem. So we might say that, okay, if deep learning can do all of these complex problems, it can solve problems which can be which we solve using machine learning, classical machine learning algorithms, right? So why we need to talk about machine learning? We can do everything using deep learning, right? So we might get this question. So obviously, there are a lot of problems which can be solved by deep learning algorithms, but it's like overkilling it, right? So there are a few problems, like in machine learning. Let's say you need to classify or identify an object, or a fruit, whether it's a mango or apple, right? How you can do that using machine learning? So in machine learning, you need to provide lots of feature, right? So for all of your data, and your feature should be very rich, right? So you might say that what is the size of the fruit, or the shape of the fruit, color of the fruit, and based on that you can predict that, okay, this particular fruit is an apple or orange. So you need to feature engineer the feature sets, or you have to extract the right feature using which machine learning algorithm can learn. Whereas in deep learning, you don't have to do that. So in deep learning, you just give the image. It has a network of neurons, which we will look into in some time. But it learns from the data itself. So you don't have to do rigorous feature engineering or feature extraction. So that part becomes a little easy in deep learning. But it's quite evident that if deep learning can do this automatically, what it takes to do that. So for deep learning, you need a lot of data set. Like you need to supply hundreds and thousands of images so that it can learn it well, right? In machine learning, you can come up with some prediction even with small data set. I mean, reasonably small data set. But in deep learning, you need to provide lots of data to the data set so that it can predict. Okay, so now if you look at the history of machine learning, it's nothing new. It's just like we are dealing with deep learning in today's time frame. But if you see a few of the algorithms that we use or techniques that we will be seeing in deep learning, like perceptron, then backpropagation, these are the things that we will look into today. But these are developed and discovered in late 1950s and late 1980s, right? But after that, we have a snoozing time. So almost till 2006. We didn't have much. So we didn't have this till this time. We didn't have much going on with this. But scientist and a mathematician and statistician, they all have come up with lots of good techniques and algorithms in the late 80s. But what was the reason that we did not have that much of progression what we had in last let's say 10 or 12 years? So one of the things that we have today, which we did not have 20 25 years back, is the data, right? So now we have plethora of data around us. If you look at your own mobile phone or laptop, you have hundreds of GBs of data, right? But think about it, 20 25 years back, we didn't even have a mobile phone, right? And for deep learning to learn, right, we need to have data. So the data was something which was missing, in those time. And most of the researchers and scientists, those theories are driven by complete, theoretical proofs. Okay, very less experiments. Okay, but now that we have data and we have adequate infrastructure like GPUs and CPUs, because you don't have to buy expensive server in your data center or a system for your own use. You can use a cloud computing platform to get the GPUs and CPUs, and once you are done with your usage, you can just destroy that. So this is very much accessible in today's day. So once you have this once you have this data, and you have this data and you have this compute power, you can do a lot of experiments, right? So you can if you include these two, you can try out new things with the algorithms that we had and what we have people have developed in over the last couple of years. So these three things enabled us to make use of a deep learning to the next extent. And that's why if you look back in last 5 to 6 years, we have seen a tremendous growth in deep learning. Right? So like automotive, car, image processing. So if you look at even the airport today, if you go to Bangalore airport, you will see that you get a boarding pass with your with face recognition, right? So they are doing some prototyping in few of the places in India as well. So these are the things that has come up because of the immense power or the compute power that we have today in our disposal. Now, so how this deep learning works, or what this deep learning is. So as the name suggests, it's actually driven by the human brain. So it's the motivation came from human brain. In our brain, we have neurons and hundreds of thousands of neurons, and we take decisions when we see something or when we feel something. So our eyes, hands, legs, nose, everything is our sensors, right? Or you can think of it as an input gauge. And once we see something, we take some action, and that action and the time between the action that we take and the time from something that we see is very fractional, right? So we our thought process is very, very fast, right? And when this has been diagnosed by a lot of researchers, they found that the reason that human brain works so well and so intelligent is because of the way that our brain is constructed with neurons, right? Where one neuron takes some input, gives that output to some other neuron, and it takes it does some operation, and again it gives the output to some other neuron, right? So what in a nutshell in deep learning is you have neurons, and it takes some input and it gives some output, right? And this output can be used by some other neuron, and it can do some operation, and it can give to some other neuron. So like that, you can have multiple neurons, okay, that we are going to see. But the whole idea is, in each of this neuron, you do some computation, and you do some transformation to the input data. So if you are giving some X data, here you get something else. Okay, so that's the whole idea of neural network or deep learning, right? And at the end, when you come up with the output, you get something very complex, right? Which we are going to see in a moment. So if you look at it, this is how a neuron, or the basic building block of deep neural network looks like. So you have this input. Okay, so you can think of this as a x1, x2, x3 to xn, and you have one neuron. So let's talk about this input. So let's say you have a data set with let's say it's a CSV file. Okay, some data set, and it has, let's say, 10 features. Okay, it has 10 features, and it is a binary classification problem, let's say. So the class label can be 0 or 1, right? So in this case, this 10 features would be, you can think of these as x0, x1, and this would be x9. Okay, these are the 10 features that you have. And now let's say this particular data set have 1,000 data points. Okay, so now what happens is all these 1,000 data points is fed to this network, or this is not a network actually, this to this input layer. So let's say you pick the first row in the CSV file. So in the first row in the CSV file, you will have 10 data points, right? So it will go to each of these, like x0, x1, x2, so on and so forth, and then you will multiply this with some weight. So this weight is randomly initialized. Okay, so you can think of this as let's say you have an data set, right? You have a data set, and you have these 10 features. So it might so happen that a few of the features are more important to do the prediction. So let's say this is the predicted value, the output or class label. So it might happen that feature 1 and this feature 7, these two are most important to get the right class label, right? So it has a much more correlation. So in that case, maybe the weight of W1 would be quite high, and weight of W7, so maybe W7 would be somewhere here. This would be much higher than other weights, right? But we don't know actually. So this is when you open the CSV and look at it. But the whole idea of deep learning is about coming up with the right weights. Okay, the whole training time, when we will see that in some time, the whole idea of deep neural network training is to come up with this right value of weights, that W0 to Wn. Okay, so this is what these weights are. And then we have something called bias. So bias is very important. So let's say you are trying to you're building a model where let's say you want to go out to play cricket, right? So there are a lot of things that you need to check, whether the climate is good or not, whether your friends are available or not, you have all the accessories needed for playing cricket. So these all would come under input, right? These all things will come under input. But let's say you are sick today, or you are not well today, right? So in that case, no matter what is the input, you will not play, right? So your output will it will be completely independent of what are the input features, right? Because you are not well. So you can think of that as a bias. So every a neuron will have a bias. So what happens in this neuron is you can think of this neuron as two parts. One is a pre-activation or aggregation. People may call it as an aggregation, or and the activation. So in this pre-activation, what happens is you sum all these products like x0 into w0, x1 into w1, x2 and w2, and then you sum up everything. So this is written in a dot product notation. So this is actually what this is basically w0 x1 plus w sorry x0 w1 x1 and so on so forth, okay, like this. And this is just in vector notation. It's a dot product of w and x, and then whatever is the output of this, okay, this would be some number, right? I mean some vector. So whatever is the output, you will pass this to a function, okay, and this function is what we call it as the activation function. Right. So there are different kinds of activation functions available for our use, but this is what we are seeing here is a sigmoid function. So sigmoid function is is a function which 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 transform your input to a non-linearity. Okay, so this sigmoid function is actually a 1 by 1 plus e to the power minus z, and the z is nothing but this whole thing. Okay, so whatever we get from this dot product, you can put it in z. So the value of this sigmoid actually lies between 0 and 1. Okay, so we will see that, but the idea is we need to come up with some complex function. So we should not have a linear function like that. So let's say you have some data points like that. Let's say you have some data points like this, right? You have some data points like this. In this case, you can have a linear classifier like a straight line, and then you can say whatever data point that you have in this side of the line are of class 0, and whatever you have in this side of the line is class 1. So this is a linear classifier, which is very simple, and it cannot solve all the problems. But if you have some data point where the data points are mixed up, right? So let's say it has lots of different classes, and now you have to classify all of these like cross, minus, plus, and 0. In this case, you cannot draw a straight line, right? So the function that you have to come up with it would be very complex, right? There is very hard to make a decision surface for this. Right. So to do to come up with some complex function, you need to use some complex activation function. So this is what the sigmoid function that we discussed. It varies from 0 to 1, and there are different complex functions that are available like tanh, relu, and leaky relu. Leaky relu is just one of the variant of relu function. But the idea is, in each neuron, you will first aggregate the input, and how we aggregate that, we will multiply the input with its weight, and then we sum all of them along with the weight, obviously, and then we perform the activation. Right, this is the whole idea. Now we don't know, as of now, we don't know what should be the weight of these this particular model, right? That what should be the right value so that the output comes correct. So we will see that how we can come up with the right weight. Okay, so now deep learning. So this is what we discussed is perceptron. So that was like, it was invented long back in 1956, but after that, a lot of research has been done in this space, and now we have 3 different types of algorithms in deep learning at a very high level. So today we are going to talk about MLP, and then we will move into some hands-on. So what that multi-layer perceptron does is we have seen that one neuron what it can do, but it cannot solve a very complex problem. So what people have come up with is, how about taking multiple neurons and putting it one after another, right? So here we have the input layer, this we have seen before. Now let's say you put n neurons in one hidden layer 1, and then you put another layer layer 2, and here also you can have n neurons. And actually this n can be different. Like here you can have 10 neurons, here you can have 5 neurons, whatever. It depends. And then you will have some output neuron. And the idea is exactly same. You will have weights across all these neurons, and you will also have weights here. So that theory still holds true. But the idea here is each of this neuron will add some complexity, right? So this will have some sigmoid function. This will also have the sigmoid function. Let's assume that we are using sigmoid function as an activation method. So now what will happen is, when you are taking small changes in each neuron, the output function that you come up with, which will automatically become very complex, right? So it's just like if you want to build a big house, which is a very fantastic house, let's say, which you might, when you look at that house, you might be mesmerized that, okay, how they have built this. But if you look into that in a smaller blocks, they have all built that using a small brick and some cement, right? So the idea is you have to pick small changes into the data. You have to make small transformation, and you have to keep on doing it in layers, and the ultimate function that you will get would automatically become complex. So there is a fantastic paper and algorithm which I would strongly recommend you to read. There's a theorem called universal approximation theorem. So there you will see this, that how a simple function, using a simple sigmoid function, you can come out with a very complex function if you keep on adding multiple layers and multiple neurons. Okay. But still now, we don't know how many layers we want, what should be the weight, and all of this. Now, the way that it works is like this. So let's say you have a image, like this is a classical example of handwritten digit classification. So where you pass the image to the input. So let's say this image is of 30 by 30 pixel. Okay. So if you just convert it into a vector, it would be like 900 30 by 30, like 900 the length of the vector would be 900 by 1, right? So now you will have x0 to x899, right? And then you pass that data, and each will have its own respective weights, and which will be randomly initialized. There are different techniques how you can initialize, but but it would be randomly initialized eventually. And then you pass that data to the next layer, and this layer's output will go to the next layer, and this output will go to the next layer. Okay, so here we just have 2 layers. Now this sounds pretty straightforward, right? You are giving a vector, and it is doing some mathematical operation, and it is giving some output. Now, how do we check that output is correct or not? So here we got 5, but how do we check that whether 5 is correct or not? Obviously, it's wrong, but the way that we can check is we have to compare it with the class label. So the actual label of this handwritten image is 4. Now, and we got 5, so which is obviously not correct. So there are different loss functions available where you can identify the loss or the error, right? And once you know the error, what you eventually do is you tell each and every neuron, and this process is called backpropagation, because you are now going back from your output layer towards your input layer, and you are telling each and every neuron that see, this is wrong, and you need to update your weights. Because the reason that it was wrong is because we randomly initialize this weights and biases, right? And we are just going back and telling each and every bias to change. Okay, and there are different techniques that how we can change these bias and weights. And once we change the weight, so we will have an updated weights, then we again go forward, right? So this process keeps on going, and it keeps on going till we converge, or in other terms, it keeps on going till the loss becomes 0. So 0 would be like it's kind of overfit, but it should be very minimal, which we can afford to have, right? So this is the whole process of deep neural network. Okay, so now, if you look at a multi-layer perceptron, one thing that we did not discuss is how we take the output. Okay, so there are a lot of text here, but I will explain in the next slide. So here, let's say we have the problem that we were seeing is digit recognition, right? So we know that the digit could be from 0 to 9, right? And what we want is actually not one output, right? We don't want one single output. What we actually want is a probability distribution. So since here we can have a number from 0 to 9, in the output, we will have, most likely we will have 9 such neurons, okay, or a probability distribution of 9 numbers. And this soft function can help us to give us a probability distribution. So if you sum all of these 9 numbers, you will get 1. So because the probability goes from 0 to 1, and the soft max function, it's a function which can give you a probability distribution. So it might happen that, let's say you have given a image of let's say 5, okay, and then once that after all the training, you might get a probability distribution of, let's say, 0.1. So that means the first neuron would be signify that digit is 0. The second one would be the digit is 1. So its probability may be 0.1, something like that. And similarly, maybe the neuron which has 5, it might have a probability of 0.8. Okay, so whichever neuron will have the highest probability, we can pick that as the output class label. So if you look at this, let's say you are picking this image which is 5, and let's say this is nothing but, let's say, some random input, right? So let's say this, actually the class label of this is 5. Okay, we are just converting into vector, and when you pass this after the training process, it might have predicted and it has come up with some probability distribution. Here we have just printed 3. That means all of these are actually 0, right? And we can say that this particular neuron or output neuron is having the highest probability, so this number must be 5. Okay, so softmax can help us to come up with this probability distribution. And the way, if you are interested to know how that what that softmax is, so basically this is a function, right? So you can think of this as a function. Okay, and from this all the hidden layers, and ultimately the output layer might have some might come up with some numbers, right? It's all numbers, so it might come with 20, minus 17, whatever, it's just random number. Okay, 1.7, whatever it is. Now all of these we need to convert into a probability distribution, right? So the softmax function, what it does is it takes each and every number, and it calculates like this, if I remember it correctly, e to the power x. Okay, so it ranges from I to, let's say in this case, 1 to 0 to 9, right? So it basically in the denominator it adds all the numbers but exponentially, and in the numerator it just takes that particular ith element. Okay, this is how you can think of it as a normalization. So this is what the softmax function does. Okay, so now that we have seen that how a deep neural network works, let's see that how you can utilize AWS for learning or training your deep learning models. So if you look at the whole landscape of AWS in machine learning, you will find that we categorize all these services into 3 different layers. Okay, so this is the topmost layer, which is all are API based. So you don't need any machine learning expertise. You can just do it through API calls, right? So if you are a software developer or and and a front-end developer, you can always use all of these APIs. Just like you can think of this as, let's say you want to identify an image contains a person or not, and you don't know anything about machine learning and you don't care about that, but you want to integrate this feature in your application. So in that case, you may want to use Amazon Recognition. So Amazon Recognition is an endpoint service where you can just do a curl, put a request, and you just give that image, and it will return you a JSON with all the entities or all the objects that it can see in that image. So this is for software developers who are not interested in machine learning and all of these, but they want to integrate that machine learning capability or AI-based capability into their application. So you can go over these services. And similarly, we have SageMaker, and this is the broadest service that we have in machine learning, where you can train your model, deploy your model, and do the inference. Okay, and we will look into SageMaker notebook, in a couple of minutes. And then we have machine learning infrastructure or machine learning framework and infrastructure. So this is mostly for researchers or people who are doing research, or if people want to compile their own code and build their own tools, they want to have more flexibility, right? They don't want to give the flexibility to AWS. In that case, they can just take the GPUs and CPUs, and all these systems comes with all the predominant frameworks that people use in deep learning, like PyTorch, MXNet, TensorFlow, etc. So if you want to build everything from scratch, you may like to pick something from this layer, right? And we are going to see a few of them today in the demo. So these are the few of the ways that you can leverage the infrastructure from AWS. One is deep learning AMI. So this is nothing but you can think of it as a virtual machine, and but everything is pre-built. Okay, like PyTorch, MXNet, you can just create a EC2 instance, and then all of these modules will be built in, and you don't have to manage them. You can just start writing the code. And if you want to spin some container and use it, that is also possible. So you can use the deep learning containers. All the frameworks and models are pre-built inside that. So these are a few of the ways that you can utilize. And EC2 instance, as I mentioned, it's a virtual machine. You can think of a VM in the cloud. And you can take as many GPUs or CPUs or memory as you want, but you have to make sure that you switch off, shut down the instance after your usage, because otherwise you'll be charged for that, right? It's just like pay as you go model in general, what you have in in cloud. Okay, so AMI is Amazon Machine Image. You can think of it as a kind of an ISO image that we typically see in our on-premise, infrastructure, where you can pick the right AMI, like Linux or Windows or whatever, and you can just spin your virtual machine. Okay, we will see that in the demo. And it most of the deep learning instances come up, offers you the CUDA support. So now you have GPUs in the system, so you don't have to worry about speed and performance. So you can pick the right instance which you feel like. So we have various different types of instances, so you can use GPUs as well as CPUs. These are the frameworks. These are few of the frameworks. We have a lot more support, but these are the few frameworks that you can leverage. And in particularly today, we will see some demo on PyTorch. So you can use PyTorch in the Jupyter Notebook, or in an EC2 instance, or in the SageMaker Estimator. So SageMaker Estimator is something that when you want to train a model in a distributed fashion. So let's say you have a very large data set and you want to do the training, and now you know that your data is pretty big, and you need to do the training in multiple instances. In that case, you will use a high level API that we have in our SageMaker SDK called Estimator. So there you can mention that okay, I want to perform this training in 10 instances. So what will happen is your model, your training will happen in 10 different instances at the same time. and it will be completely parallel, and you don't have to manage the data segregation across those 10 instances and all that. And once the training is over, all those infrastructure which was used during the training will be perished. So you will not be charged. So let's say your training took 15 minutes, so you'll be charged only for that 15 minutes. Okay, so this is for distributed training. And we discussed that we have CUDA support, and for different frameworks, you need to pick the right instance. So if you want to use Cafe, you need to use, you have to pick the right AMI. So this is all about picking the right AMI, right? So which AMI you are using, you need to make sure that you have the right CUDA support. Okay, so with that, let me open the console and show you. Okay, so now the first thing that we are going to see is the Jupyter Notebook. Okay, so you will find that if you log into AWS console, this is the first screen that you will see if you are new to AWS. If you have been using, know it very well, that we categorize all the services in in a subcategories. Like here you have all the services for machine learning. So you can click on SageMaker, or you can just type it here. Okay, so in SageMaker, as I mentioned, it has lots of features, like you can do distributed training, deployment, training, etc. So today we are going to see how you can create a Jupyter Notebook in SageMaker. So we are going to open this, but I will just show you how you can create a Jupyter Notebook. So you just click on create Jupyter Notebook. You can give some name, and here you can pick the instance type. Okay, so you can pick, there are different instance types available. You can pick any of these instance type, and if you're interested to know which instance type come with what type of configuration, you can check the documentation for that. And then simply you can click on create notebook. You can keep everything default, and you can also link your GitHub repo if you want. This you can do it later on as well, but let's just simply create this notebook. Now this is now in pending state, so it will take a couple of minutes. So what is happening in the backend is it is creating a container for you with all the modules and frameworks built in. Okay, like I have this already created, so I will open this by the time this gets created. But once this is done, this creation is over, you'll find something like in service. Now when you open this, this is exactly same as how you use Jupyter Notebook in your laptop or any of the server. Now that I've been using this for quite some time, you see a lot of folders, but ideally you will not see any folder. And now if you click on new here, you will find all the frameworks built in. So these are the different kernels available. So you can pick any of these kernel and start using it. So this is the beauty of Jupyter Notebook. So you have not installed anything, you can just go and start writing your code. Also, there is something called SageMaker example. If you click here we have a lot of built-in algorithm that we have from SageMaker from Amazon. But not only that, there are a lot of standard tutorials and standard algorithms available. So you can use it. The moment you click on use, that particular Jupyter Notebook will be saved in your instance. And saved means it will come up here, and then you can use that. You can edit it and play around. So that's a fantastic way to start learning. So let's go into DL AWS PyTorch, and there is a small notebook which we will just go through quickly. So here, the problem or data set that we have is a Titanic data set, which is a very standard data set. You might have seen and worked on this. But what this data set is about is we need to predict people who survived or who did not survive in the Titanic crash, right? So this is the class label survived, and it's a binary classification because either the person is alive or he died. So there's a class label and all are the features, right? So once we load that into a pandas data frame, we are just reading it from the CSV. We see that there are a lot of features which are not necessary for our training. So we can drop those features. So we are just creating a variable with all the unwanted features, and you can drop these features. And once you drop, this is the data set that comes up with. So we are just doing some data munching, and there are few rows which doesn't have any data or null, and we need to clean them. So we are just using the pandas method, drop na function. And once this is done, we are just trying to do one more thing. If you see the sex column here, the feature set, it's a string, right? Male, female, and all. So we are just encoding it. So we are using scikit-learn to do that. And if you notice, we have not installed scikit-learn, right? So it's everything is installed and configured. So once this is done, we have a clean data with all numbers. Now we have to take this survived column from this data set, because this is the class label, right? So we will have features separately and class labels in a separate data frame. So this is what we are doing. We are saving the features in Titanic _ feature variable. And what we are doing as well, one more thing we are doing is in this P class, that is the which class that person stayed in the ship. There's different classes, class 1, 2, 3. We are using one-hot encoding to segregate that class to 0 and 1. So this is also we are doing as a part of feature engineering. And then we are saving the target separately. So we know that the target is survived. So this is the feature, right? Not the feature. This is the column, right? This we are taking out from this data frame to a separate data frame. Okay, so now we have the features. This is the feature, right? The output 9. This is the feature, all the features, and this is the output, right? And if you see now how many rows that we have, 714. So there are almost roughly 100 rows which got deleted because it has null. We drop those lines of data. And now what we're doing here is we are splitting the data into test and training. We are using 20% for training and rest for testing. So sorry, 20% for testing, rest for training. And once this is done, we are using PyTorch for training. This is the framework that we are going to use. And first we are converting this NumPy array into tensor using torch method from NumPy. And once this is done, we are doing the same for the training as well as the target data frame. And once this is done, here we are going to start the training. But before that, we need to mention that how many hidden layers, how many neurons you want in that hidden layers, right? So here we have specified 10. This is just a random number. And we know that the input feature has 6 columns, right? So the input size is 6, and the output is 2 because it's a binary classification. So it can be either 0 and 1. So once this is done, we can use, this NN is actually the class from, we are taking from neural network class from Torch, which we have. So we are just inheriting from there, and we are just initializing the layers, and we are using sigmoid function, which we have seen, a couple of minutes back. And here we are using softmax, but it is actually a modified version of that. So here we are using log softmax, which is quite similar, but little with a subtle difference. People generally use softmax with clause entropy as a loss function, but PyTorch, they suggest to use log softmax with NLL loss function. Okay, so this is just what is recommended by PyTorch. So we are just using that. So once this is done, we are using an optimizer. So this we have not discussed, that when you do a back propagation, we update the weights, and the idea that the idea of updating weight is such that you reduce your loss, right? And this is an optimization problem. You are trying to do something to make something small, right? So there are different techniques that we can do. We can achieve that. One of the very famous is gradient descent. You might you might have heard of this. There are different variants of gradient descent, like stochastic gradient descent, mini batch, batch gradient descent, etc. Similarly, we do have an optimizer called Adam, okay, and which is a little advanced in gradient descent, and it works pretty well. So this is the optimizer that we are using, and NL loss is the loss function which we are going to use to calculate the loss. So once this is done, we can actually write the function which can run through all your data points, right? So we are doing a forward pass. We are passing all the data through the neural network, and then we are calculating the loss, right? And once we have calculated the loss, we have to go back and update all the weights, right? So we are going back to to calculate the gradient or the weights, and once this is done, we are again doing the test so that we know that after making the change in the weights, how good our prediction is now, right? So we are just iterating over it through a certain number of times. So here we are running it for 1,000 times. So epoch is nothing but the number of times all your data goes through the training process. Okay, so if let's say you have 100 data point total and you pass all the 100 data point, okay, so if you pass all the 100 data point, that will become a one epoch, right? So now if you do the same thing again, then you are in the epoch 2. So basically, how many number of times you are passing your input data for training. Okay, so we are just doing it for 1,000 times, and when you run this, we see that accuracy gradually increases, right? Because more and more training that you are doing, more your weights are getting more accurate, right? And we see that it's ultimately we got roughly around 84% accuracy, which is not that good, but you get the idea. Now if you just plot this, you will see that the accuracy is kind of 84% after 600 epochs. That means from 600 epoch to 1,000 epoch, right? Last 400 times that you have trained, there is nothing much the model have learned, right? So this is just to show, how the training accuracy increased during the training process. Okay, so now just for the sanity, we can just do a prediction. So for that, we just take some test data. So let's say we pick that fifth row, and this is the fifth row from the data set, and the actual class is 0. Okay, so now when we do a predict, so again, this number we are just converting into a tensor first. I mean, this sample data. Okay, we are just converting into a tensor, torch tensor, and then we are trying to predict. So as we discussed, we use softmax to come up with that probability distribution, right? So this is the probability distribution it has come up with, right? And we need to pick the maximum probability. So out of these two, this number is max, right? Minus 0.1167. So this is bigger than this one. So when you just print it, you will find that this is actually class level 0. So which is the actual class, right? So it's predicting quite okay. So this is how you can use a Jupyter notebook and a framework like PyTorch. Not only PyTorch, you can change the kernel to any of these, right, and make use of deep learning frameworks. Now the other thing that I want to show you is, let me just close this, is how you can use AMI or the virtual machine with deep learning AMI. So for that, you need to, let me go back to the home screen. And here we need to go to EC2, all right? So EC2 is our virtual machine service. It's nothing but instance in the cloud. And here you can click on launch instance, and this will be a wizard. So you can just, search the one that you want. So let's say you want a deep learning, right? You want a deep learning image. So you will find all these images here with various operating system and all of that. And you can also see, what are the packages that it would come with, right? So let's select this one. And here you can select, what type of instance you want. So basically here you will see whether it has GPUs or CPUs or both, etc. So here you can filter it with GPUs, and all the GPUs based instances are here. So you can pick, by default, it has picked T2 micro, but we can pick anything, like let's say this one, P2X large, right? It is quite a a hefty instance. So then you can just click next. You can add storage if you want. By default, it gives you a 90 GB of storage, and then you can just go click, and you can just review. You can always give more access to that, but I don't think you would need. But in case you need that, you can just add the protocol and the port number on which you want the access to. So let's say this is we are just good with SSH, so you can just go and launch it. So here it asks for the SSH key. You can create that, or you can pick any of the keys. So I have one key, so I can just use that and click on launch instance. So now what is happening is it is creating a virtual machine for you with all those modules, and that instance will have your GPU as well. So to see that, let's go back and click on this instance, and you will see that it is pending and initialize. Its state is pending and it is still initializing. So let me just close this filter, and you will find that there is one instance that I have created before, and we can log into this system. Okay, so because this is a P3 2x large instance, so let me log in to this instance. So I can just copy the public DNS name. Okay, and I can open my shell and do an SSH to this. Okay, so this is the key that I have to log in to this instance. Now, when you first log in, right, you will see a welcome screen with all the virtual environments, right? Like PyTorch, TensorFlow, all these virtual environments are there. Right? So you can pick, let's say PyTorch we are interested in, right? So let's say interested in PyTorch. So you can just copy this, and you can just paste this, and now you are into that virtual environment. Okay, now if you see how many CPU it has 8 CPUs, right? And now if you want to see GPUs, we can also see that. So we have NVIDIA SMI, and you can see that it has a Tesla V100 GPU. Okay, so now what we can do is you can run Jupyter from here, and since this is a virtual machine and it's in the cloud, I have configured SSL, a tunneling, so that I can open the Jupyter notebook from my browser. But it's very simple. If you are interested to know how I have done that, I can share you that later, or I can post it in the comment section. So let's go back, and this is the Jupyter notebook. I've configured it with PEM key and authentication. And now what I can do is I can just, open it in my browser. So let's see if it works. Okay, it's not working. So let's see. Okay, so let me try this. If the SSL is okay. Now okay, so now, so this is the tunneling was disabled. So I guess I removed that tunnel. So this is how you can make a tunnel, all right? So you give that same PEM key and you just map that localhost port to your laptop, right? So once this is done, you can, now you are running this actually in the EC2 instance, right? This is coming from your EC2 instance, and what I want you to show you is quickly, if you will find one folder called tutorial, right? These are all default, which you will see the moment you create an instance. And if you go inside the tutorial folder, you will find different frameworks. Like PyTorch, if you go, you will find different notebooks. One important thing that I want you to show is how you can use the GPUs. So there's nothing interesting here, but if you scroll down, you can use Torch CUDA, And CUDA is the API and the module which helps to access the GPUs, okay, in NVIDIA GPUs in the system. So we have seen that we have a GPU in our instance. So if you run this, you will find that it returns true. So using PyTorch, you can actually talk to the GPU. And now, when you say x equal to x dot CUDA, that particular tensor or vector or the matrix is created using that particular GPU. So it is not using the CPU, it is using the GPU. Now, if you do any operation like x plus y, right, it will also be using that GPU. So that way, when you are building your model, you can use CUDA to make sure that you use the GPUs. Okay, so let me just quickly open the same model which we have just ran in Jupyter Notebook, but this time we are going to use GPUs because earlier we have used just CPUs, right, in the Jupyter Notebook, but now we will be using the GPU. So it's just a one-line change which I want you to show. Rest everything is same. So if you come here, if you see here, we have device equal to torch.device CUDA. So I've just written one to show you something, but since this has only one GPU, you can just write CUDA. But let's say you had 5 GPUs. So in that case, you can say it's 1 or 2 or 3, whatever it is, okay? So by default, it will always pick the first GPU. And then what you do is when you create the tensor, you can use this method dot CUDA and the device name. Then automatically your tensor would have a device type of CUDA, right? So this is what you all we all want, right? So why we need GPU? We need GPU so that our computation becomes fast, because a system has, the system which has GPU can work parallelly, right? It can do parallel operations. So if we define our tensors in different GPUs, and then if you perform any matrix multiplication or differentiation or anything like this is what in the Adam, all these optimizer, all the algorithms, what they will do is they will all perform a lot of calculus or and differentiation, to be very precise. So those operations will become very fast, right? And once this is the only change. Rest of the code is exactly same. So basically we just change the tensor to make sure that it uses the CUDA device. That's all. Rest everything is same as before. So that's how you can use an AMI. So what we have seen is how you can use a Jupyter Notebook. This is what we have seen, and how we can use deep learning AMI. Okay, so this is something which is missing. So maybe if we get a chance, I will try to have one more session which is only to deep dive into PyTorch estimator, where we can discuss about how we can train a model in parallel into multiple instances. Okay, so with that. Let me see if you have any questions, or if you have any queries. I would love to hear. Or else, this is what I had, and please feel free to reach out and stay connected. And I would like you to scan this code. You might get some credit. Which you can use to play around all of these, right? And in case any of this credit doesn't work, just ping me over LinkedIn or somewhere, or send me an email. I will try to give you the right code. Okay, so that's all I have for today. If you have any questions, you may like to ask now, or you can reach out to me at later point in time.
Thank you, Suman. Like we have a question which is populated in the chat box.
Okay, yeah, I see that. Give me a moment. Let me read through that. Okay, yeah. So that's a very good question. The first question is, how do we select the right activation function? So let me go back to Let me give me a moment. Okay, yeah. So here, if you see, this is, if you look at this sigmoid function, right? If you look at this sigmoid function, this is the one of the first linear nonlinear function which has some nonlinearity, right? So which is not a very strong distinction between two different classes. So, but if you see this, it varies from 0 to 1. Okay, and as and when it approaches a bigger number, right, in this side, it goes to 0, right? So now if you think intuitively in neural network, what we are doing is we multiply the weight and the input, right, and then we keep on adding them. Now, if and it happens in a chain, all right. So in sigmoid function, what happened is gradually, we come up with a problem called vanishing gradient. So suddenly you will not find much change in the weights, right, because of the sigmoid function, because it is not able to differentiate. So in that case, what people generally use is ReLU or leaky ReLU. So ReLU is actually uh, it's actually below 0, it's all 0, but before that, after anything greater than 0, it's exactly the same. Like here, how the ReLU function is defined is this one is it is x for anything if x is greater than 0, and it is 0 otherwise. Okay, it is 0 for anything which is less than equal to 0. Okay, so this is this function is proven to be much better. And although you see that again this has a problem in the left hand side, because it's all 0, similar to in sigmoid what we have, right, when it goes in the left hand side. But what people came up with is a leaky ReLU, and if you see, it is not actually 0. If you go so 0 line is here, right? It is little slanted, and the reason that it is little slanted is, in this case, we are using exactly same as ReLU, but in place of x, we multiply that x with a very small fraction. So let's say 0.001 x. Okay, so in that case, we never go to 0. Okay, so this is why this function works pretty well. So ReLU is something that people are using very predominantly, and I guess this works very well with most of the machine learning models or deep learning models. Okay, I'm sorry, this is not this one actually. This 0 is replaced by uh, a. This is the function actually, a multiplied by x. So here it's actually, what it's saying is max of 0.1 into x. So whatever is the max, that's the value. So this is how that ReLU function works. So this is, if you look into activation functions, leaky ReLU is something that people have been using, and it's all based on experiments. There are theory behind that, but this is what people have been using. Okay, so the next question is, what are the better ways to initialize weights? Okay, this is a very good question. How can we, let me just discard this. Okay, how can we update the weight? So the question is, we are randomly initialize this weight in all the layers, and during the back propagation, we are updating the weight. So what is the best way or right way to initialize the weights? So there are different techniques available how you can optimize or come up with the right initialization. Uh, so one of the way there are multiple ways, but let me first show you how there are different techniques, but all techniques are based on this. So let's say you have a neuron, and you have these inputs. Okay, and this neuron has, let's say, 2 or 3 inputs, so output. So you can think of this as one of the hidden layer, right? This, let's say, hidden layer x. Okay, and then it is going to a hidden layer y, right, the next layer. And in the next layer you have 3 neuron, and before this, let's say hidden layer A, right? So from here, it has 4 neurons. So if you pick any neuron, this 4, we call this as a fan-in, right? This is what we call it as fan-in. And we have 3 neurons here, 3 outputs here. We call this as a fan-out. Now, using these 2 numbers, the scientists have come up with different optimization weight initialization techniques. So when we say, if you just forget about all of these, when we say we pick W randomly, it is always we pick from a normal distribution. Okay, so or to be very specific, we pick that from a Gaussian distribution. Now, this is a normal thing, right? Which we just do it randomly. But using this, fan in and fan out, a lot of scientists have come up with different techniques. One of them is Xavier's initialization. And what Xavier's initialization does is, it says you pick from a normal distribution, which ranges from A to B. Okay, and this is the 2 range. And what A is nothing but root of 6 divided by the root of these 2 values, fan in plus fan out. Okay, so in this case, it would be 4 plus 3. Okay, and this is A. And what would the B? B would be exactly same, but the positive, so it would be positive 6 root 6 divided by root 7. So what Xavier's initialization says for this particular problem is, for this particular neuron, we can pick the weight as the from the normal distribution of A and B, where A is minus root 6 by root 7, and B is plus root 6 by root 7. So this is one of the techniques. Similarly, we have something called Hayes initialization. In Hayes initialization, it's quite same, but in that case, it doesn't consider input and output. The fan in and fan out. It just says again, it would be a normal distribution between A and B, and A would be minus, not minus root 6, it would be minus 6. Sorry, not it would be 6 by root of fan in. Okay, and this is minus, and the other range would be plus root 6 by fan in. Okay, and this root won't be here, it's only root 6 by fan in. So this is another scientist called his initialization that they have come up with. And one of the point that we were discussing in the initial stage is, because of this lots of compute power and data that we have, people started to experiment. So these all came, so if you ask how this root 6 came into this picture, I mean, what is this magic number, and who came up with this, like fan in fan out thing would help to pick the right weight. So these all actually came from experiment, although we do have lots of theory behind that now, but these all came from experiment. So you can use Xavier's initialization or Hayes initialization, and there are different other ways, but these are the different ways that you can initialize your weight. Okay, so what is the next question? The next question is TensorFlow or PyTorch. What would you recommend? See, it depends upon what you are using, but what people generally use is they use multiple frameworks. But PyTorch, what I've seen and learned from other people around me is it has very rapid growth in last couple of years. Facebook have invested a lot. And in fact, Amazon and Facebook have come up with a new module of PyTorch as well, which is .serve. You can search it in the internet. You will find some link. But you can explore things in PyTorch a little easily because it has higher level APIs. But if you want to dive deep and try to do something more, you can always use TensorFlow. But having said that, it's all up to you. If you are starting off, you can pick one of them and build on top of it, and then gradually pick the other framework. It won't be that difficult. It's I mean, over the period of time, you would learn which framework to pick for which type of problems. Almost all the problems can be solved by all these frameworks, to be very honest. But yeah, there are few advantage or a few special optimization done by few of the frameworks, which we may like to use. Okay, so there is one question. I think Shrija, we are shooting up the time, but I hope it's okay if I just continue for 5 more minutes.
Yeah, no problem, Suman. We can
Okay,
continue if
sure.
it doesn't bother you. Yeah.
Okay, cool. Yeah. Okay. The next question is, what would you recommend recommended way to learn AI ML uh, uh, for a web developer? Okay, cool. So uh, see, there are a lot of information available in the internet, right? So what I would recommend is you can pick any of these, right? You don't have to ask anyone. You can pick, you can spend one day in the internet and find the best resource. But the more you search, the more overwhelming feeling that you will have, and the more confusion will inject in your brain, right? So what I mean, this is what this is what happened with me as well. So I would recommend that pick something which you are really comfortable with. From AWS standpoint, you can go to this website, ml.aws. We have a machine learning university, which is now open to everyone. Previously, it was only for the employees. So you can take all the courses. It starts from basic to linear algebra, probability, statistics, to advanced machine learning techniques. So you can follow that, or there are different courses available in Coursera or edX. You can pursue any of these, and but honestly, just pick the thing that you are you are getting. Okay, it's not like if I'm telling you some course or book, you have to follow that. It's not like that. So you can, but whatever you pick, just stick to that. I think that would be that would be the only advice that I can give, because that is something that which I did wrong, right? So I used to hop around different things based on different people's advice, and all of these advice are correct, but it's just me who who was not able to manage everything, right? So pick the right one and then stick to that. And you are a web developer. That's actually very good. So you can in machine learning, once you build model and all of these, right, you have to deploy it, right? So I was struggling to deploy one of the model in the cloud using an web API, because I was not coming from web development background. Although I found a few very good tool, but if you know web development, you can always vision big, that if you can learn something in machine learning, the end part, you can master it very well, because at the end of the day, you have to showcase your model, or you have to show your work to the outer world, right? So if you are a web developer, you are kind of you have some skill sets which you can leverage once you get some head around machine learning. So I hope that if you are comfortable with one of the programming language, especially if you have played with Python, it would be very useful. And yeah, there is nothing prerequisite. Like you will see that machine learning people, learn at various age and at various experience level. But you just need that passion to keep learning. That's all, and rest rest will follow. Okay, so there is one more uh, question. Auto ML, what is the uh, method of hyperparameter tuning which is more effective? Oh, okay. Auto ML or trial and error? Okay, that's a good question. So auto ML is one of the feature that we have in SageMaker, where you can, even if you do not know which algorithm to take, which parameter to select, which are the correct hyperparameter, you can just ask a SageMaker. SageMaker can help you with that. So this is always good, but trial and error might take a lot of time. But always remember that if machine can do everything, right, we don't need a human being, right? So what where auto ML people use is when you have very complex data or problem to solve, and you don't have enough bandwidth and enough information regarding that problem. In that case, you might go with auto ML, right? And then auto ML will suggest you different algorithms or different hyperparameters. But after that, you need to take your own judgment, right? So a SageMaker will not tell you that, okay, use this only, because at the end of the day, you have to say that, okay, you have given me these three options, I will go with option two. Okay, that judgment you need to do. And before you do that, you anyway have to do that trial and error. But but your work towards that optimizing that right hyperparameter tuning will go down if you use AutoML. So always use AutoML, but it's always good to check that what AutoML is doing is actually correct or not, right? So most of the time it's correct, but there are few instances where it's not able to come up with the right hyperparameters. But it is very in those cases you will also not be able to come up with the right hyperparameters because of the data set that you have. Okay, that is also possible. But I would recommend that if the data set is completely odd and you have no idea about domain expertise, you're not the domain expertise and you don't have much understanding of the data set, then you may try AutoML. And if the data set is small and you can get some head around, it's always good to do some trial and error, and then you can cross check your own hyperparameters with an AutoML run. Right, it just runs multiple hundreds or 50 time and come up with its own prediction, I mean own best classifier and hyperparameter. So it's good way to check yourself that where you are going. Okay, so is there any question? I'm just scrolling up. Give me a moment. Okay, yeah, so I think that's all that I have. And I want to show you one more thing, which I forgot. Maybe I can, people who know about this, can ignore, but I just learned this just a couple of days back. So I'm just pasting this link. Okay, and I'm also pasting this link, just 1 second. If you have just one moment. Okay, yeah, so this is the link for to get the credits. Okay, so this is a fantastic way to visualize how neural network work, where you can give some, here they have just 4 data sets. Okay, so you can pick any of these data set, and this is a two feature data set, x1 and x2. You can increase the number of neurons, decrease the number of neurons, and you can just start training. Okay, and you can see that how it converges. Okay, and here you can use different activation functions like tanh, relu, sigmoid, and you can see that how a complex function can be classified. So if you see here, after 100 epoch almost, it can classify blue points with orange points, right? But if you see, if you take this complex data, and if you start training, you'll find that even with 1000 epoch, right, it is not able to classify. If you see, it is still not able to classify all of these, right? And one interesting thing to see here is the the thickness of the line, right? And this is what we were discussing. That means that this is having higher weight with respect to this weight. This is the random weight that it is picking up, right? Now if you just stop this and add these two features, like this is a feature engineered feature, right? X sin x and sin x2. If you do that, and then if you run, you'll find that the model is able to come up with a, the training is able to come up with the right model. Now if you just stop it here, you see that it is able to classify orange almost quite nicely. Also it is able to classify the blue points, right? So this is a fantastic place where you can just play around neural network. You can spend hours on this. I was just playing around this for last 2 days to see different things. So I just thought to share with you because I had no idea about this, fantastic playground. It is offered by, TensorFlow. So kudos to those guys who have built this. Yeah. All right. So with this, I'll call it a day, and feel free to reach out. Thank you so much for joining, and thank you so much for your time. Feel free to ping me over LinkedIn or Twitter, wherever you feel like. We'll be happy to help you. Okay, with that, thank you so much, everyone, and thanks so much, Shrija, for all your time and having me in the session. Thank you.
Thank you so much, Suman, for the insightful session on the deep learning, I would say. And also at the last for your tips and the handful of resources for the the people who are interested in deep learning and ML. And so yeah, we ran out of time. That's okay. Like we had an amazing session today, and probably like if participants have any questions, probably you can send it across to me. I can collate it across and send it across to Suman. And thank you, Suman, for the wonderful session, and thank you everyone for attending this session. And uh, until then, thank you. Bye.